Alright, hi. Today we're going to talk about the law of sines and cosines, which is a new investigation into what happens if I don't have a right triangle. Okay, so for example, what if we're working with a triangle that looks kind of like a little bit like, oh, sorry, I'm trying to get the right example up. Alright, so what if we're working with a triangle that looks like this? Okay. Now the law of sines actually comes from a lot of proportions in geometry. Okay. So I'm not going to go into the proof exactly right now. You can learn that in college and just work with it there. But for right now, you can actually use law of sines to get a lot of great information out of this. Like for example, these two missing sides could be attained by the law of sines. Okay, now one important thing is usually in law of sines you're dealing with triangles that you know, well, let me get rid of these, where you know two angles and a side, okay, or two sides and an angle. Okay, so like where you have ASA, you know two angles in the included side, or you know AS, those ones, and then the infamous SSA. Now we're not going to deal with that as much. You'll actually learn more about that in trig. But those do pop up in ambiguous case of the law of sines. Okay, but for right now, some really cool things you can do. Well, guess what this angle is? This is 180 degrees minus the 55 minus the 30. And you're probably asking yourself, why is that? Well, because it's the inside of a triangle. Okay, so let's 95 degrees. Had to think about that for a second. Okay, so now that that's 95 degrees, you can do a lot of cool stuff with this. And this is how the problem's going to be set up. All right, so it's going to look something like this. Sine of 30 over 8 equals sine of 55 over C, which equals sine of 95 over B. Okay, so depending on what you're looking for, you can use this, because now what we have is that if I use this combination, or if I use this combination, I can cross multiply to get a missing value. So that's what you're going to do exactly, okay? So, okay. Let's move that off to the side then. Okay, so if we cross multiply with the first one, we get C times sine of 30 equals 8 times sine of 55. And remember, these are just two decimals. So it's C times some decimal equals 8 times some decimal. Okay, so what do I need to do? I just go ahead and divide both sides by sine of 30. Okay, and I should find out what the exact value of C is going to be. Well, in all actuality, it's probably not going to be an exact number. So it's actually an approximation, okay? But it's going to be about 13.11 is what the value of C is going to be, or 13.1, you know. So the cool thing is that you can actually use law of sines with non-right triangles to actually get it. And basically you're setting up a problem where you're going to cross multiply and then divide by the number next to the variable to get the actual value of the actual problem. Okay, now law of cosines is usually used when you are dealing with triangles where you know all three sides but you don't know any of the angles, or if you know one angle that is sandwiched in between two sides. Okay, so let's take a look at an example problem for that one. Okay, now before we start on this problem, I want to go look at the law of cosines. If you notice something, the law of cosines, the first part of each of these formulas, well, guess what? They look a lot like the Pythagorean theorem, and that's because they kind of are. Okay, now the extra stuff at the end helps us figure out the rest, and once again, long, complicated proofs are how you actually get those extra pieces, so we're not going to worry about that as much right now. Okay, we're just going to go ahead and solve this problem. All right, now what I usually tell students, okay, if you're doing SAS, you can start with anything, and honestly, I would probably mess around with the one that gets you side C. So if you feel like you can replace A, B, and C with anything, that's totally fine. But for this problem, I would probably use this one because we're looking for side C. Okay. All right. So we plug everything in. Okay. So that it would look something like this. Okay. Now, when I simplify everything, I need to make sure, and this is the important part, that this square plus this square, I do not just subtract this number, because this number is times by cosine of 37. So when I work it down, it's going to look like this on the next step. Okay? And then when I simplify it, I'm going to add these two. So 121 plus 64 is 185. So it's going to look like this. Okay, now I don't just subtract things and go, oh, that's going to be 9 times cosine of 37. No, 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 no. You have to calculate this first and then subtract it from 185. Okay? All right, and so make sure your calculator is always in degrees because we're in geometry. So 185 minus 176 cosine of 37. All right, and that whole thing should turn into 44. Oops, stupid thing. This whole thing should turn into 44.44. Okay, now am I done? No, because if you notice, this is just c squared, and I want c. So I have to square root both. All right, and look at that. You're going to get the sign of the beast. That's horrible. That's not a good omen at all. Okay, but anyways, that's how you get the answer for that one. Now, my recommendation for working with SSS ones, where you know all three sides, I would always recommend this, find the angle opposite the biggest side. Okay, if you do that every time for SSS type triangles, you should be good to go for those, okay? So literally just find the angle for that. It's a little bit trickier work to find the angle, but if you simplify it down to just the cosine and the letter angle you need, it should be a lot easier. Let's see an example. You know what? Let's see an example on the next page. Okay, so for this one, this is definitely an SSS triangle. I would probably find angle A first because I'm using law of cosines, and I've learned in my experience, and I've had past teachers say, if you just find the angle opposite the biggest side first, it makes your job so much easier because you don't have to interpret a whole bunch of stuff. So we're going to set it up like that. Okay? All right. And so what we can do is reclassify a lot of these. So this becomes 81. 5 times 5 is 25. This becomes 64. 2 times 8, or 8 times 5 is that, so that turns into 80. Okay, all right, and then when I add these two, I should get an 89. Okay, now what I'm going to do is I'm probably going to subtract 89 from both sides. Now, is that okay to get a negative number? Yes, it is. It's going to be totally okay. So this should be negative 8. Okay, now what I'm going to do is I'm going to divide both sides by the negative 80. Okay, and this is the part where I was talking about. So negative 8, or I'm sorry, negative 80. We're going to divide it by both sides by negative 80. Okay, that is one ugly negative 180. Okay, so now what happens is this turns positive. Even if it was negative, it would still work. Okay, and so you could basically say 1/10 is what this looks like, and it's just cosine of angle A. Okay, now we're not going to divide by cosine, but we're going to do the arc cosine of both sides. Okay, or the cosine inverse. It's up to you how you want to say it. Okay, but what happens end up being is that this cancels out, and I'm going to go to my calculator real fast. And this actually turns into 84.26 degrees is what angle A will equal. Which makes sense because it should be the largest angle out of all these angles inside this triangle, okay? All right, but that's it for working with law of sines and law of cosines. My recommendation is, before we leave, My recommendation is use law of cosines once, then I would use law of sines in this problem, then use triangle sum theorem, okay, to find the missing angle, because now when you get this angle, you can find one of these other two angles through law of sines, and then since you have two angles, you just subtract those from 180, and you should be able to find this missing angle. Okay, and you should be good. All right, that is it. I will talk to you guys later. Bye.